So in this video, we're going to learn about friction. Friction is kind of an interesting force. It has sort of a nature to it that makes it a little bit smart. And also, there's some counterintuitive aspects. For example, many people think that friction sort of goes against the motion of the object, but I'm going to show you that in fact it doesn't always do that. Why don't you pause and read through these three objectives I have for you in watching this video, and then start it again. We'll get to the video. All right. To start off, I want to imagine a scenario where we've got a person pushing on a book across the table, and they might be able to get the book moving, something like that. But as they start to push, they don't actually move the book. You could imagine pushing the book, but not so hard as to make it move. And for that scenario, let's draw a free body diagram. So this is pushing the book, but not enough to make it move. I'm going to ignore the vertical forces since I'm mostly interested in the horizontal forces here. So this is force person on book. And here's force table on book. But this is a friction force. So we'll subscript that, or we'll indicate that with a script F. Now, if we're pushing just as hard, that object won't accelerate. It's at rest, so it stays there. That's what I wanted you to imagine. Pushing, but not hard enough to move the book. All right. So now I want to imagine another situation where we take this guy and slide him over here. I want to imagine another situation where we push a little bit harder, but still don't move the book. So there's me pushing harder. Force person on book. And friction pushes back just as hard. Well, it has to if the book's not going to move. And of course, you know that you could push harder and harder. At some point, I suppose the book would move, but not at the beginning. So friction sort of has a smart aspect in that it seems to respond to how hard you push. Now, let's imagine pushing a little harder yet. So here's where I'm going to be pushing, and I'm going to be pushing so hard that the book is just about to move. Right on the verge of moving. So at that point, since the book still is not accelerating, again we have a balanced person on book, table on book. But that's the break point. And you push any harder, and then the book will accelerate from rest. All right, so let's imagine that situation next. Let's go to the situation where the book is about to move. Excuse me, the book has accelerated from rest. So now we're pushing hard enough. And when that happens, the friction force actually drops to be smaller than it was there. Person on book. Friction table on book. So that's kind of interesting. So once it starts to slide, the friction force actually becomes lower than when it was at rest. And we'll take a look at why that might be coming up. But for now, I want you to recognize that that's the case. Again, there's that. This is yet a different length, but this has been smaller than that. And let's do one more where the object is moving really fast. All right, so at this point, I've drawn another situation where we're pushing even harder, and the friction force hasn't changed from what it was before. Let's grab that, move it up to my little graph there. And what I want to do is make a graph of this scenario that we just took a look at. So here's what happens. As we don't push, friction doesn't push. As we push harder, friction pushes harder, and then at some point, the box or book accelerates from rest, starts to slide, friction drops off, and then the friction force stays constant no matter how fast, no matter how hard we push. The friction force sort of flatlines right in there. And in the next segment, we'll take a look at why that might be.